Okay, so we are moving on to one of your last graphing lessons, which is 12, and this pertains to, again, what we call a phase shift. So a phase shift is the only direction you have not yet moved your graphs in, and this is horizontal left and right. So a phase shift is going to be horizontal movement left and right. So horizontal movement to a graph left and right. So left and right. Okay. Now, when you did transformations back to geometry, you spent a lot of time shifting your graphs. So anytime you took something and moved it to the left is actually going to be associated with a plus. And a right-hand movement is going to be associated with minus. These always work backwards or opposite. So you want to think backwards. Okay. So what we're going to do here is label a graph. We're going to significantly change your window. And we're going to take this original graph and phase shift it. Okay, so number one, and I'm going to review a lot of vocabulary as we go through this, just because I think it would be helpful. So number one says to graph y equals sine of x in the interval from 0 to 4 pi. So we're going to double your graph. So sine of x first. Okay, what's the amplitude of this? Just 1. So that's going to be the highest value I have to hit, as well as -1 as the lowest. The next thing I want to be able to pull from that is I'm looking for what is my frequency. So that's just the number in front of the x, which is just 1. And this graph has no midline whatsoever. So this is in its basic form. So when I go to scale this graph, I know I have to hit up to 1 and down to -1. Now I'm going to look over here. Does this one also have amplitude of 1? It does. So I'm going to label 0. And then I want to space this so it doesn't look like it's a smushed graph. So I'm going to do this. I'm going to go every other. So this would be 0.5. This will be 1. This would be 1.5. This will be 2. And then back here, I'm going to go -1. And then I'm going to go -2. Okay. The next thing I need to do is take my x-axis all the way to 4 pi. So we're going to start this, and this is just like how your graphs have been labeled. Pi is approximately 3. So we're going to count 3 tick marks and label our first increment here. So I go 1, 2, 3. And our standard interval is pi over 2. Then we go 1, 2, 3 pi. 1, 2, 3, 3 pi over 2, just like you're used to seeing. I go again, 1, 2, 3, 2 pi. Okay, so that's the extent of what you've done so far. Now, all I'm going to do is just continue this. And there is a pattern. So if this is 1 pi over 2, and this is 3 pi over 2, do you guys notice those are odd numbers? So now I go 1, 2, 3 tick marks. And this is 5 pi over 2. 1, 2, 3 tick marks, and that's 3 pi. 1, 2, 3 tick marks, and that's 7 pi over 2. And lastly, 1, 2, 3, and that is where I end at 4 pi. So we are going to type that in the calculator in a minute because I want you to practice that as much as possible. So we're going to graph just a sine curve, the sine of x, amplitude of 1, and you're going to see what happens when you phase shift. So calculators out, please. And what I want to do quick is point to these before we actually type these. And if you struggle with the calculator, go ahead and label these. So when I pull up the window, what is the smallest x value on here? 0. 0. What's the biggest value on the x-axis? 4 pi. Second to the right. So like right here, 7 pi over scale is always right of 0. So this is going to be pi over 2. Our y min is going to be right here, -2. And our y max, we're going to label as +2. Okay, and our scale went by a half. So pull through those calculators. And again, all you do is you read these right off the graph. So again, you're going to check to make sure you are in radians. I'm sorry, give me a moment. My calculator's frozen again. So make sure you're in radians and see if you can start typing that in without my help. Where is my? All right, trying to get this working again. Things in this building like to freeze a lot. All right, so we're in radians. Give me one moment. All right, so back to your calculator. You're going to hit window. And your X min. All right, so your X min is going to be 0. Your X max is going to be 4 pi. So 4 pi. And then we are going to go, X scale was pi divided by 2. Y min was -2 for us. And Y max was +2. And our scale was 0.5. Okay. Now you're going to go back to the Y equals. And you are going to type in sine of X. So just sine of X. And you're going to hit graph. Okay. And what you are going to see is 2 complete sine curves from 0 to 4 pi. Okay. So when you go to this, you don't, it's difficult when you have so much to do. You go 0. Right here at pi over 2 on that 1, 0, -1, 0, and then all you do is make an identical copy to the right of that. Okay. So you're remembering the numbers 0, 1, and then -1. Those are the only ones that you're going to actually graph. All right, so I'm going to go 0, 1, 0, -1, 0. Again, this part you've done before. And now I'm going to make another identical copy on the other side. So 1, 0, -1, 0. So I'm going to go right up and through these. Okay, that's your first one. Again, keep it color coordinated so you can look back at it. The next thing we're going to do is we are going to take this and we're going to apply this called a phase shift. So we're going to move it, and we have plus this time, so we are going to move it to the left. So this is going to get moved to the left, pi over 2 units. You can do this by hand or with your calculator. It doesn't make any difference. If you want to do it by hand, all I do is I look at my existing graph, and I'm going to move it pi over 2, which is 3 boxes. So I would take this point, pick it up, and move it right here. I would take this point and I would move it 3 this way, because that's pi over 2. I would take this next point here and go 1, 2, 3. Next point, 1, 2, 3. Because again, pi over 2 is 3 boxes on here. Next, I go 1, 2, 3. And actually, I'm going to stop it right there, and then we'll make an identical copy. what you're going to notice when you connect these is this is a cosine curve. So you can apply different transformations and obtain identities, is what this is called. Okay, so we took a sine curve and we did a phase shift to obtain a cosine. Now I just continue this on the other side. So this is going to be 0, -1, 0, and 1. So just like that. And back up. And this is, I'm going to color coordinate again, my orange graph right here. Okay. So what you wanted to think is you were going to move each of those points 3 boxes. Or go to your calculator, clear out what was there, and then continue and plot your points. So it says this graph of y equals sine of x moved pi over 2 units. Again, plus goes left, where its amplitude was still 1, frequency was still 1, and period would be 2 pi divided by frequency, which is still 2 pi. The next one you don't have to actually graph it. I just want you to see what would happen. So this one is x minus pi over 2. So this would move pi over 2 units, and then minus goes to the right. Nothing else would change at all. Amplitude 1, frequency 1, period is still 2 pi. Okay. Next thing we're going to do is phase shift a cosine curve. So we're going to set up your graph one more time here. It's going to be the same thing as above though. So I'm going to go 0, and then I'm going to count 3. 1, 2, 3, pi over 2. 1, 2, 3, pi. 1, 2, 3, 3 pi over 2. 1, 2, 3, 2 pi. Now I'm just going to double it. 1, 2, 3, 5 pi over 2. 1, 2, 3, 3 pi. 1, 2, 3, 7 pi over 2. 1, 2, 3, 4 pi. Done. And our y-axis, can we still go by the same thing as above, but we just have amplitude 1? Yep, so just the amplitude 1 to get it on your cosine curve. So I'm going to go 1 and then 2. And then -1 and -2. And then we're going to go right to the calculator and you're going to type it in. I'm going to go back to the calculator. Again, I don't have to make any changes to the window. It's the same as above. And I'm going to go y equals, and I'm going to just simply change it to cosine instead. So I hit graph. And again, this is going to model the graph paper that's right in front of you. And that's all you're going to do right there. So my first point is up at 1, 0, -1, 0, and then back up at 1. All right, so I'm going to create that picture again, and then you're going to just make another identical copy. So we're going to go 1, 0, -1, 0, 1. And again, what you're going to notice if you look up at the last example we did is the cosine of x is actually equivalent to the sine of x minus pi over 2 that we did. Okay, so there's that. I continue this way and back up. All right, so that one's all set. So the next thing you're going to do is you're going to type in cos of x minus 3 pi over 2. Now, I'm going to show you how to do this in the calculator, just in case you want to do it that way instead. What's crucial with this is how you type the 3 pi over 2. So you have to use the fraction template. So I'm going to go to the calculator for those of you that favor that. And we're going to type in instead. I'm going to go cos, and I'm going to go x minus, and I'm going to go alpha y equals, enter. And I'm going to place in the top 3 pi. And my denominator is 2. Okay. And then you're going to go ahead and hit graph. And if you've typed this correct, you should have this image right here. And that's all you're going to place on your paper. So again, you're going to start at 0, drop it down to -1, 0, 1, 0. All right. So I'm going 0, -1, 0 to start this. So 0, -1, 0. Different color, please. So 0, -1, 0, 1, 0. I'm getting connected. And all I'm going to do is copy that image on the next side. So it was here, now it goes down and then back up. Translate all your points, and you're good. So this is another phase shift. And your amplitude is still 1, as well as your frequency. So this one I'm going to color coordinate too. If you wanted to do this by hand, what you would do is move it 3 pi over 2. So that's from here to here, so that's 9 boxes. Again, if you favor doing it by hand. So now I just summarized this. So this one here, both of them have amplitude equal to 1. Frequency equal to 1. And the periods were both 2 pi still. Okay. Because this was minus, this would have been a phase shift to the right by 3 pi over 2 units. All right, so your next one, all you're doing is just feeding information. So what is the period of this function? So for number 3, I'm going to go period is equal to 2 pi divided by frequency, which is right here. So 1/3. Then I'm going to do keep change flip. So I do 2 pi over 1 times, flip it, 3 over 1, and go right across. 2 times 3 is 6, and then the pi is attached at the end. Okay, so 6 pi. All right, how do we feel in the phase shift so far? Pretty good? This next one takes 2 seconds. So identify your phase shift with amplitude of 2, phase shift of 90 to the right. To the right is going to be minus. So I can omit choice A and B. And a phase shift is always going to be located inside the parentheses, which is choice D. Okay, that was choice D. Number 5, I'm going to skip and we're going to come back to that tomorrow. Okay. So the last one I want to do is down here, number 6. This is another word problem application to make sure we're good with these formulas. We're going to put this whole question on this side. I know it carries on to the back of the next page, but we can fit everything right here. So don't worry about parts B and C on the back. So it says, in an amusement park, you have a small Ferris wheel called a kiddie wheel. The points on the circle in the diagram represent the positions of the car. The kiddie wheel has 4 cars and makes 1 revolution every minute. That is the period. It has a diameter equal to 20 feet. Okay, I'm going to start with that. So your Ferris wheel is located 5 feet off the ground. So this right here represents your minimum value. And now what about the people all the way at the top? How high up are they? 5 plus 10 plus another 10 would be 25 feet is your max. So the next thing we need is to sketch this. So I'm going to draw a little axis here. Okay. I know that my minimum is 5. So 5 goes right here. I also know that my maximum is located at 25. I'm going to go from there. And then I know that I need to do this rotation for 2 minutes. So here's 1 minute, and here's 2 minutes. Okay. So, quick and easy. You're going to start on the Ferris wheel. You're going to get on it. And then what's it going to do? Goes up to its maximum. And then it goes back down. So we go just like this. It says to sketch it for a second time as well. I go up to my maximum, down to my minimum. And that's it. So on the back, you are asked for the equation. So that's the last thing we're going to go through today. So to create the equation, I need to make this say y is equal to a cos of my frequency times t plus my midline. So the first thing we calculate is the amplitude. Amplitude, you did this on homework, is equal to maximum minus minimum, bless you, divided by 2. So maximum is 25. Minimum is 5 divided by 2. So 10. The next thing we need that would be helpful to do immediately is your midline. So my midline is equal to my max plus my min divided by 2. So I have 25 plus 5 over 2, which is 30 over 2, which is 15. And then the last thing I need is my frequency. And then I just put all this together. So period is equal to 2 pi over frequency, when frequency is the letter B. And the period was the time it took to make one full rotation. So that right here would be 1 minute. So I go 1 is equal to 2 pi over B. Cross multiply, and I get B is equivalent to 2 pi. Okay. All right, so I'm going to plug everything in. So my answer is y equals. Now, who remembers? What do we have to do because this flips? It starts at the bottom. Negative. Good. So negative in the front. Amplitude is 10 times the cosine of 2 pi times t plus the midline value of 50. Okay. So that answers the questions that are on the back of that page. So you can cross that off if you'd like. And all I want you to do for homework, I'm going to flip to it. So again, you may omit those. We already did that. I just didn't want to make you flip back and forth. So we put it all on the one page. And for homework, all you need to do is just 1 through 3 only. And the scaling on those graphs is the same thing that we used. Okay, so just 1 through 3. Please feel free to use those calculators. You still got 5 minutes. Wanted to give you time to at least get them started. But remember, count 1, 2, 3 spaces. And your first increment is pi over 2.